Now we'll begin with Chapter 1 on equations and inequalities. Our first section is on linear equations. A linear equation in one variable is an equation equivalent in form to ax plus b equals 0, where a and b are real numbers and a cannot be 0, because of course what would happen if a was 0, we'd have 0 times x, that would go away. B is just a constant, so we'd have some number equals 0, wouldn't be an equation. This is a first degree equation because the highest power on the variable is 1. The value of the variable that makes the equation a true statement is called the, what do you think that is? The value that makes it true. The solution of the equation. Now, first degree equations can have as many as one solution. Second degree equation, this becomes plural and so forth. But for a first degree equation, you cannot have more than one. But do all equations have a solution? What do you think? Well, let's see if we can come up with an example to prove that that is not true. What if we had worked in a problem, we're simplifying, we get it down to 2x minus x equals x plus 5, and we keep going to simplify. Of course, 2x minus x is 1x, x equals x plus 5. Is there some value for the variable x that will make this true? No. If we put in 0 for x, then we're saying 0 equals to 0 plus 5, or 0 equals 5. And of course, any other number is not going to work either. So this is a case where we would have no solution. Or you may have seen another way of writing that as an empty set, where there's nothing in there. You wouldn't use both of these for an answer. It's either no solution or maybe an empty set. But that's an example of an equation that has no solution. Can they have infinite solutions? Any number works. What do you think? Let's see if we can come up with one. I have x plus 6 on the left and negative 1 plus 2x plus 7 minus x on the right. So let me simplify my right-hand side. This one I can't simplify further. I've got 2x minus x, that's 1x. Negative 1 plus 7, that's positive 6. I could subtract 6 from both sides, and what do I get? X equals x. Well, of course, whatever I put in for x, this is going to be true. So this is an equation with infinite solutions, and these have a special name. They're called an identity. It's an identity if all real numbers are the solution. Okay, let's look at example 1 and solve a couple of linear equations. Notice that example 1, we have some fractions here. Personally, I like to get rid of the fractions and get to integers as fast as I can. And I know that if I multiply both sides of the equal sign by the least common denominator of all the denominators in the problem, it will get rid of the fractions and I'll have integers. So I start by saying, what is the lowest number that 7 and 4 will both divide into? And turns out it's 28, 7 times 4. So I'm going to multiply both sides of the equation by 28. Now I could break this thing up and have x over 7 minus x over 4, distribute the negative, all that stuff, but this is what I prefer to do. One step and I'm done with fractions. Notice how this works. 28 times x divided by 7 leaves me with 4x. And now here I'm going to have 28 times the entire numerator divided by 4. So when the 4 goes into the 28, it leaves me a 7. But that 7, very carefully here, it's not just times the x, it's times the x minus 1. If I forget to put the parentheses, and I might end up at the wrong sign here. And then 28 times 3, and we get 84. Okay, now we use the distributive property. Negative 7 times x, negative 7x, negative 7 times negative 1, positive 7. Combine like terms, 4x minus 7x, and subtract 7 from both sides. and we get negative 3x equals 77. Now we'll divide both sides. I'm running out of room here, but I'm going to write this by negative 3, and I get x equals, and I'm going to move my negative to the numerator because that's what we're used to seeing, negative 77 over 3. I like to put mine in the brackets to make it really clear. Here's my solution set, negative 77 over 3. Okay, part B also has fractions. Now, I'd really like to just get rid of them. One step and they're gone. Notice one step gone. I'm going to multiply by the LCD of 3 and 7. That, of course, is 21. Both sides of the equation. Don't forget, both sides. Okay, when I multiply 21 times x plus 1 and then divide by 3, that 3 goes into 21 7 times. So 7 will be multiplied by x plus 1. And 7 goes into 21 3 times, will be multiplied by x plus 2. And 2 times 21 is 42. See how simple that's going to be to solve? One step. Okay, distribute 7x plus 7 plus 3x plus 6 equals 42. Combine like terms, 10x plus 13 equals 42. Subtract 13, 10x equals 29. I believe that's right. Let's see. Yes. And divide by 10. 10x divided by 10, 29 divided by 10, and I get x equals 29 over 10. 29 over 10. We want a simplified fraction, no mixed numbers, unless we're working an application problem that asks for mixed numbers. Otherwise, we'll have improper fractions or just regular fractions in simplest form.